A very good day everyone, we are Group 56 under Dr. Ali Samir. We are presenting our engineering team project called X5bin. Now, let us meet our team members.
Hello, my name is Amiratu Husna Azhar. My student ID is 18002346. I'm taking chemical engineering.
My name is Muhammad Shamim Suhaimi, 1802362, Department of Mechanical Engineering.
Assalamualaikum and good day. My name is Muhammad Adi Farhan and today I will be representing about results and discussion.
Hello, my name is Melinda Joseph from Mechanical Engineering Department. My ID is 19001441.
My name is Lim Zin Yu. My student ID is 18002572. I am from the Department of Civil Engineering.
The project background of this project based on the fact that most electronic devices has limited lifespan and frequently replaced every 2 years by discarding or sell it at the second-hand merchandise. Waste electrical and electronic equipment was the fastest growing waste stream in the world, and the growing concern of the waste is lithium-ion batteries are not be handled and recycled safely. Lithium fire can occur if this battery end up in the skip at the recycling center or in an office waste without being properly managed. Next, we have identified the problem statement that leads to the idea of X5bin. As known, COVID-19 has shown many impact in everyday life, and due to MCO, the usage of electronic items has increased. Old devices and in-use devices are prone to damage, which contribute to the increase of electronic waste after repair. Hence, repair center must have a safe electronic waste storage, as some are hazardous and flammable. The design of X5bin is mainly focused on SDG 12, which is responsible consumption and production. The objective of this project is to design a smart bin that can safely detect, alert, and automatically put out unwanted fire from e-waste. The second objective is to enhance response times toward the fire incidents while minimizing risk toward the user. And the last objective of this project is to prevent the loss of property and life through early alerts and on-spot fire suppressing action.
There are a lot of fire cases related to electronic waste. One of them happened in e-waste recycling center in Melbourne North. The incident happened due to inappropriately large stockpile of e-waste. It was stated that the recycling center is one of the state's largest e-waste operator. Secondly, the incident happened on December 2016 due to lithium-ion battery. Among the huge pile of waste, lithium battery are also virtually invisible, and that may be the real danger with these batteries. Lastly, the incident occurred on 4th of July 2017 at West Plant in the West Midland town of Old Berwick. The fire cause is due to hot ashes, lithium batteries, gas cylinders, flammable liquid, and aerosols. Lithium batteries are a particular concern in this case. Most smart bins out in the market are only designed specifically for the general use of waste bin. These smart bins are not equipped with smoke sensor and fire extinguisher to prevent fire cases in electronic waste management. Even though smart e-waste collecting box is out in the market, which focus on cost-effective and user-friendly smart household, it was discovered that ultrasonic level measurement might be incorrect in some scenarios because the chosen sensor, HCSR04, is a low-cost sensor and might register a false echo when e-waste is deposited into the collecting box. Design thinking application. Emphasis, generate idea and do some survey. Define, set the objective and problem statement. Idea, consider the problem, SDG related and effectiveness of the product. Prototype, test or validate the idea and elaborate the working solution. Test for better understanding and clarification of solution for the problem.
Now, I will be explaining on the working principle of X5bin. On the left, we can see all the features of X5bin and the function of each component. Combining it all, we have the working flow of X5bin for fire protection of e-waste. It mainly revolves about 3 steps: detection, alarm, and operation, which is carried out by using a smoke sensor, the buzzer, the Arduino Uno, solenoid valve, and a fire extinguisher. The smoke sensor is used to detect the fire, buzzer is used to alarm the occupants, and solenoid valve along with fire extinguisher is used to conduct the fire protection operation. Moving on the left is a circuit diagram that connects all the electronics components in X5bin, including the smoke sensor, buzzer, Arduino Uno, solenoid valve, and power supply. A 12-volt power is supplied to a solenoid valve and stepped down to 5V for the Arduino, buzzer, and smoke sensor by using a MOSFET level shifter circuit on the left breadboard. On the right, this is the simulation results of the level shifter circuit, and the electronics components are diagnosed to be connected perfectly. The methodology that we have taken to come up with the idea of X5bin starts with doing extensive research with the online publications, and we find out that a problem exists with the e-waste file protection. Then, our team had an open discussion to come up with several ideas and approaches to solve the problem. We have also conducted survey with predefined groups for more insights. After obtaining the feedbacks, we have finally come up with a design and did several improvements on the XPower bin to choose the best components. Finally, we summarize our findings in the final reports.
This is the isometric drawing of X-Fire bin. You can see we have the top view, the front view, and also the side view. Our X-Fire bin is divided into two compartments which are welded together. As you can see, the bigger compartment which has the hole there is where the e-waste can be thrown into. The secondary compartment, which is much smaller, is where we place the electronic components and also the fire extinguisher. The height of our X-Fire bin is only 0.91 meters, the length 0.68 meters, and the width 0.45 meters. Hence, you can see that our X-Fire bin is not that big, so users can move it freely and easily. Our e-waste volume that can be stored is 66 liters, a very big volume considering its size. Here is the rendered design of our X-Fire bin from all angles. We designed it using Fusion 360. Now let's watch an animation video. They just can throw their e-waste as usual. Suddenly a fire comes from the e-waste. So what happens next? The MQ2 sensor detects the smoke from the fire and sends signal to the Arduino. The Arduino sounds the buzzer and sends signal to the solenoid valve to release the high pressured CO2 powder, and the fire is put out using the CO2 powder. The buzzer stops sounding, and then the user can retrieve the SD card and replace the fire extinguisher. As easy as that.
Second survey's first question, we asked the public how would they rate our finalized design for X-Fire bin from scale 1 to 5. Majority of the respondents vote 5, which means the design is totally acceptable and excellent. Second question of the survey, we asked the public about the level of satisfaction of X-Fire bin regarding their functionality and purposes. Well, majority of the respondents vote 4 and 5, which means they agree with the purposes of the X-Fire bin. Based on our third question, majority of the respondents agree that our product is aligned with SDG 12 goal, and it is also the same goes to our last question, which is the majority of respondents agree that we have achieved all of our set objectives for X-Fire bin. This is table of component price list included in the X-Fire bin. From the table, the total raw cost of our product would be the grand total of RM415 unit plus. The total cost of this device is acceptable considering the nature of firefighting industry standards, which demands high quality and durable components, which makes some main components highly priced. First recommendation for X-Fire bin is that it can be attached with sensor which will help to monitor the type of waste of substance in real time. An easy and friendly application for X-Fire bin can be made in order to assist and help the user monitor the condition of X-Fire bin.